Okay, we are talking now about operations on functions. The specific new idea is going to be compositions of functions, which might be new for some of you, might be review for some of you. But we're going to look at operations with functions: addition, subtraction, multiplication, and division, which, if you remember how to add, subtract, multiply, or divide polynomials, for example, that's what we're going to be looking at. And then we'll build into the idea of this compositions, which we will finish off next week. So, compositions are going to look like this: C of T of D. So hopefully we're comfortable at this point that something like this would be read as f of x. So now we're going to throw in something like this, and it's going to be read as g of f of x. Function compositions, this is an example you can read about when those would be applied. So cost of heating on a given day in the year. Now, basic operations with functions, so like g minus f of x in this example here. So g of x, so this is just g of x minus f, which is x squared minus 1 minus x minus 1, which is x squared minus x. Swing. So, very straightforward. Just take g and f and subtract them. X squared, there's no like term, so it stays the same. We have negative 1 minus negative 1, which is really negative 1 plus 1. So that's why those cancel out. And then we should be subtracting x. Boom. Next one, f over g of x is f of x over g of x, which is x minus 1 over x squared minus 1. We do want to simplify here. So we have a rational expression, we want to simplify. The way you simplify a rational expression, if you remember, is to factor the top, factor the bottom. Top doesn't factor. Bottom factors as, we've got x minus 1 over x plus 1 times x minus 1. X minus 1's cancel, so we end up with 1 over x plus 1. Okay? So are g minus f of x and f over g of x the same? Well, look there and there. Are they the same? They sure are not the same. So that's how we do basic operations of subtraction and division. Multiplication will work pretty much the same way. This is just f times g, which is x minus 1 times x squared minus 1. If you distribute, you're going to get x cubed minus x squared plus 1. If we want to be sticklers with making sure things are in descending order, we'd write this. Okay? So, basic operations with functions, hopefully we're comfortable with. Just adding, subtracting, multiplying, and dividing, in this case, polynomial expressions specifically. Now, compositions. So we're looking up here. If f of x is x squared and g of x is x plus 2. So we've got this, and so f of g of x, right? If we had f of 2, we would take our function f here and we'd plug in 2. So that would be 2 squared, which is 4. So f of g means we're going to take this g of x and plug in right here. So f of g is going to be x plus 2 squared, which is, and this is an algebra thing that we need to make sure to not fall into the trap, it's x plus 2 times x plus 2, which is going to be x squared plus 4x plus 4. Some people would be tempted to say that this is x squared plus 4, right? Don't say that. Don't be that guy. The squared does not like distribute to these two. You have to do x plus 2 times x plus 2, distribute, FOIL, whatever you want to call it, and you get this answer. Now we're going to look at g of f of x, which can be written as g of f of x. So hopefully you're comfortable with this symbol right here is composition. Read g of f of x can be written this way. So based on how things are defined, we're just going to take f of x, which is x squared, and plug it into g. So we could even write this as g of x squared, which is just x squared plus 2. Can't simplify that at all, so we're done. So after looking at those two, we can see f of g of x gives us x squared plus 4x plus 4. G of f of x, this way, is x squared plus 2. So is composition commutative? So that would be saying, is f of g of x the same thing? Is that the same thing as g of f of x? And we can see, again, here and here, that no, absolutely not. Those are not the same thing. So is it commutative? No, it is not. We will learn later something special about f of g and g of f. For today, don't worry about it. It's not commutative. They are not always the same. Sometimes they are, sometimes they aren't. Now, if C of S is number of calories burned completing S sit-ups, and S of T is the number of sit-ups a person can complete in T minutes, what does C of S of 3 mean? So, S of T, starting with the inside. We always start with the inside. S of 3 means in 3 minutes, how many sit-ups can we do? And C is the number of calories burned for doing however many sit-ups we did. So this expression right here is just going to tell us the number of calories burned in 3 minutes. So 3 minutes is going to give us some number of sit-ups that we don't know, and the number of sit-ups is going to give us the number of calories that we don't know. So the only thing we know from this notation is the 3, and that tells us the minutes, because it's the input for S, so T is minutes. So 3 minutes, that output will tell us how many calories have been burned. So again, just like on the other side, just an example of when composition of functions can be useful. Moving on to the table. So if we have a table of values, what is f of g of 3? Always start on the inside, like I said up here. What is g of 3? G of 3 is 2. So this is asking f of 2. F of 2, we can see from the table, is 8. G of f of 3, similarly, is g of, even if we come over here, f of 3 is 3. So it's g of 3, and what is g of 3? That's 2. So function compositions will always work inside out. You do f of 3 first, then g of whatever number you get from this. Do g of 3 first, then f of whatever number you get from this. So that's the basic idea. Hopefully that gets you a good start on your homework and the quiz that we'll have posted tomorrow. So hopefully you're watching this on Thursday. It's when you're supposed to. And then I will be sending out one quiz tomorrow on something called a growth mindset. You may or may not have heard about that. And and that's not really a quiz, it's more of a survey. And then there will be a quiz. It'll be graded as like a homework assignment, but just a quick little quiz on these ideas, compositions and operations, just so that I can get an idea how well you understand it, and we'll revisit all of that stuff when I'm back next week.